Hopefully everybody can see this on the screen now. It's quite difficult for me to target this at any one particular group, person or company. So what I've tried to do is I've tried to give a basic coverage of all the aspects which I feel is important. If there's certain companies or people that would like more information, please contact me at any time. Also, if there's companies that require a little bit more information on a type of aspect that we're talking about, we may be able to create a bespoke course for you and your staff, which we're quite happy to do so. Please contact us here at the AEMT and we'll see what we can do for you. Right, okay. Let's start with the serious stuff first. Wherever there is gaseous atmospheres, vapors, or even dusts, there is a potential for explosions to happen. One of the most famous ones, because they made a movie out of it, was the Deepwater Horizon. In 2018, the cost to BP was £65 billion, and that was 3 years ago. More importantly, there was 11 lives lost. Piper Alpha, one of the UK's worst accidents that happened. Unfortunately, 167 people lost their lives on this oil rig. Some of the bodies have never been recovered. Again, this is the serious aspect of what happens when you are working in hazardous areas and you're putting equipment into these hazardous zoned areas. Buncefield, 2005. I'd say luckily there was no deaths, but the 43 people that were injured wouldn't class themselves as lucky either. The explosion was that big, it measured 2.4 on the Richter scale. A huge, huge explosion, all down to petrol fumes. And it's not just gases and vapors that can cause explosions. Dusts can be just as explosive. Here's a corn silo before the explosion. And there's the same corn silo after the explosion. I'm going to take you back to school now. So what causes the explosion? I'm going to talk about gases now. There's a hexagon for dust, but we'll focus on gases or vapors. You'll need a fuel. The fuel is the gas or the vapor. Oxygen is all around us. The fuel and the oxygen has to be at a certain percentage for it to create an explosive mixture, for then to be an ignition source, whether it be a flame, heat, maybe an electric motor sparking to cause the explosion. We all know what it's like to light a gas ring or a gas barbecue. You can be clicking that igniter many, many times until that fuel and oxygen combination is perfect to cause ignition. This is what is needed to cause an explosion on a site. So how do we counteract that with protection methods for electrical equipment? There is many different types of EX concepts, but with us being the AEMT, I'm going to talk about rotating machinery and the types of protection for those. So we have an EXD. The method of protection for that is it contains the explosion. EXE, it is increased safety non-sparking. EXN is a non-sparking concept, as is EXT, where the ingress protection and the temperature are critical. And then we have EXP, which is protection method is pressurization. We're going to go through each of these concepts in a little bit more detail so we can understand what they are, what they do, and what the methods of protection are. So as we can see here, in the red, in the hexagon, we have zone 0 for gas, zone 20 for dust. That means there's a permanent presence of gas or dust in that environment. No power equipment will go in a zone 0 or a zone 20 environment. You will have intrinsically safe equipment, and you do not get a rotating machine which is intrinsically safe. The next step outside there is an incidental presence of gas or dust, which is classed as zone 1 for gas, zone 21 for dust. It has an equipment category of 2. And we now have EPLs, equipment protection levels, and they are GB for gas and DB for dust. We then have a step away from that even further, which is an accidental presence. This is zone 2 for gas, zone 22 for dust. It has an equipment category of 3 and an equipment protection level of GC for gas or DC for dust. It's amazing how many people get confused when they see DC for dust. Notice this is uppercase. Whenever you see an uppercase D or an uppercase G, it is relating to gas or dust. Temperature is critical for EX equipment. Temperature rises can potentially cause ignition. So they're put into categories. This is for gas again. You will find that dust equipment has the temperature written on the nameplate, not a T class. So we have T1 to T6. The reason we have the arrows there on the screen is for when we are teaching people in the classroom to understand that the temperature of the equipment is completely different to the temperature of the environment. A piece of T1 equipment cannot go anywhere apart from a T1 environment because the temperature will reach 450 degrees. A T1 piece of equipment cannot go into a T2 environment because the gases in that area will explode possibly at 300 degrees. Okay, does everybody follow that concept? Late arrival?
Yep.
Yep. Okay. So, nameplate markings. If you cannot read a nameplate, this is how I say on the courses, you cannot repair EX equipment. You need to understand what you have in front of you. You need to understand what the markings mean. So the CE mark, we've all seen that on our equipment and things that we have. It means it's compliant with the European directives. The next number, which people get confused with, this is actually the notifying body who inspects the manufacturing process. It's got nothing to do with the certification of the motor. The hexagon is the EX mark for EX products, sorry, the EC mark for EX products. The next one you have is a Roman numeral 2. In this case, the 2 means it is for the surface industry. If you had a Roman numeral 1, it would be for mines, underground use. The next one, which we have spoken about, is category 2 equipment. And remember, category 2 works in zone 1 for gas and 21 for dust. On this example here, we have a G, uppercase G, which means it's for gas. On a lot of equipment, we see EEX. The first E is just basically replicating the CE mark. It tells you it's European. That is starting to disappear. But EX is telling that it is EX protected. It's EX explosion proof type of equipment. The next is the concept. Whether it be a D, a P, an N, in this case, it's an E, increased safety. The next thing along the line then is telling you what type of gas it runs with. This says 2C. 2C is the most dangerous type of gas and dusts. Whenever you see a C on European and IEC equipment, not America, we're not going to talk about America, they have their own rules. But 2C is the most dangerous type of gas, which means that this equipment will work with any gas. Because the whole point of EXE means it's non-sparking. It will never be an ignition source. Then we have the temperature classes, which we just looked at, T4. That is 135 degrees. Then we have the EPL, in which case this is a B, and it's a B for gas, which is the uppercase G. If you've noticed the nameplate, it repeats itself somewhat. All modern equipment does. I think this is the manufacturer's way of making sure they are covering themselves. We have gas numerous times. We have gas, tell you what type of gas it is. We have the category of equipment 2, B, 2, B, 2. Okay, they repeat themselves over and over again. So this is how a nameplate actually looks in reality. All the information I've just shown you is here. We have the CE mark, the hexagon EX, surface industry, category 2 equipment for gas. It's an EXD protection concept. It is for 2C gases. The temperature class is T4. And again, the EPL at the end, it's still as it is for gas, category 2. The EPLs line up with the categories. Me and a colleague, we've created a little song in the classrooms. If you want to come to the classroom, you can enjoy that. We have the EPLs are A, B, C, categories 1, 2, 3. Quite an easy way to remember. It is only the zones that are misaligned. You do not repair zones. You repair the category of the equipment. This is why we're trying to move away from the zones, concentrate on the equipment protection level and the category of the equipment. So here is an older nameplate of an EXE. If you notice at the top here, there is no gas type. That is because the manufacturers back in 1979 realized that, or thought that people repairing EX equipment knew what they were doing. And they knew it was for gas and it would work with any type of gas. So again, we have the T3 here for the temperature. T3 is 200 degrees. Then we have down here TE times. This is the, again, I'm going into a bit too much detail, but the TE time is how long it would take to reach temperature under locked rotor conditions. So if it was to reach T2, which is 300 degrees, it would take 12 seconds. To reach 200 degrees, it would take 8 seconds. Here's an older Brook Crompton nameplate as well. As we can see, all the information is here again, which we saw in the information string. This is category 3 equipment for gas. The European E, EXNA, non-sparking, T3, 200 degrees. And we have another EXD. Again, information string across the bottom, T5, which is 100 degrees. Type of gas, B. Surface industry B type gases. And it's for gas. It's category 2 equipment. You notice there's no EPL because this was certified in 2001. You come on the courses, we will explain to you this piece of information at the bottom here will actually tell you the standards you require to make sure that this equipment still complies. Many people get confused and think that you recertify equipment when you're repairing it. You do not. What you are doing, the repairers are doing, they are making sure that the equipment still complies with the standard to which it was manufactured to at the time. That is all repairers do. If you want something recertifying, you need to go to a notifying body. Do we have any questions so far before we start going into the concepts of EXD? Nicola? Okay, so it looks like there isn't. Okay, right, EXD. So EXD is category 2 equipment for zone 1. It has an EPL, GB. And as you will see on a modern nameplate now, this would be pronounced as an EXDB. Another question here, we're coming through. Right, well, that's a very, very long question, and we'll look at that later on. Okay, so what does an EXD do? We mentioned earlier, it contains the explosion. The escaping gases are cooled through flame paths. Now, flame paths you will only find on an EXD piece of equipment. The type of gas is important because depending on the gas, it depends how it would explode, how violent that explosion would be, how much energy that explosion would have. And exactly the same as the volume of the chambers. So we call the volume, the chambers of an electric motor is the inside of the motor. They may be 1, 2, or 3 chambers inside that motor, which could be ignited if the gas was at the correct percentages and there was an arc or spark inside that equipment. Depending on the size of the volume, depending on the amount of gas in that chamber, would determine how tight the flame paths would need to be and how big the gaps would need to be. That is all determined on the volume. Again, we'll show you how to calculate that, how to look at that, how to find the correct tables if you came on one of the AEMT module courses. So I mentioned flame paths. How do flame paths actually work? Well, if you look at this one here, this is an experiment. And if you can see in the center of the screen there, that's a little shim. And they have filled that box with gas. It's late. They've filled that box with gas, they've ignited it, and the flame has escaped because that gap is larger than what is acceptable. And how they would do that, so if a flanged flame path, the maximum gap would be 0.2 millimeters, and that's 0.2 of a millimeter, so it's quite a small gap, but this is the maximum gap allowed for a flanged flame path. So there's an illustration of a flanged flame path, and there's no gap at all, so there will be no transmission of flame. So there's no risk of an explosion inside the enclosure, getting out, fully energized to ignite the outside atmosphere. If the gap was only 0.12, it is still within the maximum gap, there would still be no transmission of flame. It will be cooled and will be losing its energy before it ignites the outside atmosphere. At 0.18, there would still be no transmission of flame. The gap would still be arduous enough for the flame to lose its energy before it got outside. If that gap was above the maximum permissible gap, and it came out at 0.25, that could be possible transmission of flame. This is why any repair facility will record and measure and inspect all the flame paths on EXD equipment to make sure that there is no possibility of this ever happening. Obviously, on an electric motor, you have rotating parts. That is what electric motors are all about. You didn't have a shaft on it, you just have a box full of electricity, wouldn't you? Obviously, because the shaft has to rotate, there needs to be a larger gap. The flame path on this illustration is there, just before the bearing. The bearing housing, the bearing casing is never a flame path. It will always be either before the bearing or after the bearing. The reason why the rotating joint can be larger, because as the shaft rotates, the hot gases are spiraled out down the shaft, and again, it takes longer for them to get out, and they are cooled and their energy is lost. So, basically, in EXD, it has standard equipment and parts internally, because it is the motor body and the enclosure which is the protection concept. Strong, cast flame paths, making sure that nothing can escape which can ignite the outside atmosphere. You also need to make sure which type of gas an EXD motor is going into. The AEMT on our modules, we focus the practical sessions on EXD because there is so much more to check, inspect, measure than there is on any other concept. Any questions on EXD before we move on to EXE?
Carl, quick question.
Yeah.
Denso tape, because it happens.
Sorry, say again.
Denso tape, because it happens. You see it wrapped around flanges and God knows what. I know it shouldn't be there, but what's
actually, yes, it can be. It can. Denso tape can be used. It's more of a 60079 part 14 for installation. You'll never have a repairer wrapping Denso tape around a terminal box, but it is allowed. It is allowed by the standard, but there is only a certain amount of layers depending on the type of protection. The standard also says you can put non-setting grease it's mainly for IP, isn't it, on EXDs?
Exactly, yeah.
Yeah, you can use a non-setting grease. People say, can we use Hylamar? The answer is no, because if you look at the spec of Hylamar, it has evaporating solvents, and the standard says you cannot use anything with evaporating solvents. The argument with that is Brook Crompton use it. Brook Crompton are a manufacturer, they can do what they like. On their drawings, they will have Hylamar either before the flame path or after the flame path. Repairers are not manufacturers. If you can get the drawings from Brook Crompton, then fine. You'll be able to put the Hylamar where the drawings say the Hylamar goes. But in general, don't use Hylamar.
Right, so a single wrap of Denso is acceptable.
Yes, again, all that information will be in 7914 for installation, and will probably tell you the amount of time you can go around for B-type gases or for C-type gases. But Denso tape is allowed.
Okay, thank you.
Okay. Any other questions? Okay, let's move on to EXE. So EXE is category 2 equipment for zone 1, just like an EXD. It has an EBL of GB because it's category 2 equipment for gas. So we have GB. Remember, 1, 2, 3, A, B, C. On the nameplate, you would look now and it would say EXEB. So it's telling you it's category 2 equipment. So EXE is increased safety non-sparking. It removes the ignition source. So if it has no ignition source or ignition capabilities, it can work with any gas. Reduces the risk of temperatures, and this is the temperatures anywhere on an EXE, inside and out. Remember, the inside temperature has to be maintained because it's not allowed to cause an explosion inside due to heat, unlike an EXD. An EXD can arc and spark and have a little explosion inside it all the time because it's the outside concept, the build concept, which is the protection level. This is taking the flint out of a lighter, if you like. It will not arc or spark, no matter how much it tries. The rewinding of EXE should be performed with caution and with the manufacturer's help, because the windings of an EXE have been designed specially, never to be stressed, never to be put under load. They have a special insulation system, special varnishes, special winding techniques. If you can get the information from the manufacturer, perfect. If not, just be careful. In the standard, in the repair standard, there is many criteria of what you need to achieve if you're going to rewind an EXE. We'll go through these on the courses, and basically comes out of why you really shouldn't without the manufacturer's help. Ingress protection is very important. If you think about it, you don't want a conductive dust or moisture getting into a terminal box of an EXE because it is designed never to arc or spark. Creepage and clearance. Creepage is the tracking from one terminal to another across the floor, across the base of it. Clearance is the tracking in air. So again, if you had a conductive dust inside there, the clearance could be reduced. The rotor to stator air gap, which we'll talk about in a moment, it needs to be done. It needs to be looked at and checked and inspected. Any rotating parts from stationary parts need to be checked and measured and inspected. The whole concept of EXE is non-sparking, increased safety. Anything that causes heat, anything that causes friction, anything that is terminals are too close together that could cause an arc or a spark needs to be the correct creepage and clearance, the correct gaps from rotating and stationary parts. All of this information will be found in the standard to which this piece of equipment was manufactured to at the time. Okay? You then get combination concepts. You can have an EXD motor body with an EXE terminal box. These have been created for maintenance people so that they can take off a terminal box, check the resistances and insulation resistance to earth quite happily without having to worry about flame paths and so on and so forth. It is then called an EXDE. With the introduction of EPLs, we have a very nice little string now, and it's called an EXDBEBGB. Quite a mouthful. Basically, don't get too worried about it. It's just an EXDE. It's just telling you that the EXD is category 2 equipment for zone 1. It is telling you the E concept is also category 2 equipment for zone 1. And it is telling you that both of those, the whole machine, is for gas and for category 2 zone 1. Again, repeating themselves over and over again. So if somebody doesn't come along and go, oh, EXD, I can put that in a dust environment. So let's have a look at EXNs. This is category 3 equipment for zone 2. This is an EPL of GC. Again, category 3, 1, 2, 3, A, B, C. 3 lines up with C. You can see at the bottom there, it says EXEC. EXNs are now moving into the EXE category because they are very, very similar. They are non-sparking pieces of equipment. So they are now being moved into the EXEC category. I can see lots of questions and problems in the coming months and years. People saying, "Oh, we can't rewind this. It's an EXE." If it's an EXEC, you can. If it's an EXEB, you cannot. Or you shouldn't, without the manufacturer's help. So it's similar to EXE. EXN is fundamentally a non-sparking concept. Again, the rotor to stator air gap needs to be looked at and checked because it's non-sparking. Same as the creepage and clearance needs to be looked at because it's non-sparking. But there are standard windings in this piece of equipment, so it can be rewound. Then we can move on to dusts, EXTB. It's category 2 equipment for zone 21. Remember, anything to do with dust starts with a 20. 20 is for intrinsically safe, category 1 equipment for dust. Zone 21 is category 2 equipment. And category 3 equipment for dust is zone 22. As an EPL, DB, category 2 equipment for dust, or DC, category 2 equipment, sorry, category 22 equipment for dust. So again, EXT is very similar to EXE and EXN. It's fundamentally a non-sparking piece of equipment. You have a conductive dust in there. It could arc or spark. If it arcs or sparks, it could then cause a little explosion. It then would disperse the dust. If the motor was hot, that dust cloud could then be ignited. This is how dust explosions happen. They can be quite dangerous dust explosions because one explosion then leads to another, classed as dispersion. If you drop something on a dusty environment, you see a cloud of dust coming up. Yes? So a little explosion will cause dust to rise into the air. That is then ignited, that will explode, and then another area of dust will rise and will also get ignited. The rotor air gap again needs to be sorted out and needs to be checked and looked at. And again, creepage and clearance, because again, fundamentally, it's a non-sparking piece of equipment. When I've been mentioning rotor stator air gap, when a piece of rotating equipment, the load changes, the energy has to go somewhere. A lot of the time, there's a little arc or a spark between the rotor and the stator when load is changed or when it is turned off. We've all seen a light switch. When you turn a light switch off sometimes, you see a little spark behind the light switch. That is the excess energy dissipating somewhere. But remember, an EXE, an EXN, an EXT are non-sparking pieces of equipment. So how do they stop the rotor under load condition, on different load changes, arcing and sparking onto the stator? What they do is they reduce the rotor in diameter. So they make the gap between the rotor and the stator large enough so that an arc can never occur. When these pieces of equipment come in for repair, that needs to be checked. Because if it goes back and the rotor has been changed at some point because you don't see this piece of equipment every day for 5 years, if the rotor has been changed at any point for God knows what reason, and somebody's put a larger rotor in there, it fits, but it no longer has the gap that doesn't create a spark anymore. You are signing the equipment off and sending it out into the world saying it complies to the standard it was manufactured to. Make sure the paperwork meets the requirements of the standard it was built to. EXP. This is category 2 equipment for zone 1. EXPX is category 2 equipment for zone 1. It can be used with gas or dust. EXPY is category 2 equipment for zone 1. EXPX, again, same, it's been repeated. And EXPZ is category 3 equipment for zone 2. So what's EXP? EXP is an enclosure, and inside that enclosure you have equipment, but you also have inside that enclosure an inert gas or clean air set at a pressure greater than the outside atmosphere. Imagine a balloon full of air. When you press it, your finger bounces back. This is exactly what the dangerous gases or dust would do. They would be kept out of that enclosure so they can never get in there to cause an explosion. So like I've said, it is standard equipment inside the enclosure. Gases or dust cannot get in, and it can be used in gas environments and dust environments. So lots and lots of questions are asked to me on these courses and on emails and so on and so forth. And people say, oh, I need certifying so I can work on EX equipment. The AEMT do not certify you for working on EX equipment. We train you to work on EX equipment, and we give you training which is recommended by IECEX. We assess you on your training, and we give you a certificate to say that we have assessed you on your training and we are happy with how you have performed on that training. The biggest responsibility lies with the user, the owner of the equipment. Who's responsible for repairing your car, ladies and gentlemen? It's yourself. And you need to make sure that it goes to a good place to get repaired. And it's nice for you to receive some paperwork saying what work they have done and they have carried out. And you keep that piece of equipment as a service history so that when you're selling it on, the next person sees how well it's been looked after. This is the best way I can explain how we should be looking after EX equipment. I am now quoting from the International Repair Standard. This isn't my idea, this isn't what I think, this is what's actually written in the standard. The user is explained as an organisation or person which is the owner or operator of the equipment, and that is primarily responsible for repairing it. The user is not the equipment manufacturer or the repairer. Again, another quote from the standard: the user should consider whether sufficient facilities and competencies are available to undertake the repair or overhaul by themselves, or whether it should be contracted out to a specialist repairer and overhaul service provider. But if they do that, the user has to ascertain that the service facility concerned can demonstrate compliance with the relevant stipulations of this document, which is the International Repair Standard for EX equipment. The user has that responsibility. If the user isn't asking for that information, then the repair facility doesn't have to give it to them. If an incident happens, it is the user's problem. The user has to explain why they have fitted a piece of hazardous area equipment into a hazardous zone, not knowing the full specifications of that job, not knowing that the measurements were taken, not knowing what standard it was repaired to, not knowing that the repairer was competent or been on any training courses. This is all the user's responsibility. This is what people don't understand. Again, The equipment user should be aware of any relevant legislation in respect to periodic inspection and verification that electrical equipment installed in exposed atmosphere is fit for purpose. So making sure it is fit for purpose. That's the user's responsibility. How do you know it's fit for purpose if you haven't got the correct paperwork back? In addition, the user should be aware that sufficient information has to be provided to the third-party service facility, the repairer, and that information to installers to meet health and safety obligations. The user has a lot of responsibility. The ideal scenario is that the user and the repairer work together. The service facility shall conduct an assessment of the equipment. Give all that information to the user, and the user should then agree that that work should be completed. All of those conversations, as we say on the course, should be done in writing, on emails. So in 5 years' time, when there's a problem, let's hope there never is, but if there was a problem, an incident, you can't turn around and say, oh yeah, I spoke to him, he said on the phone I could do that. No, you have paperwork. Paperwork is king. Always make sure all your paperwork is in order. You have agreements in writing between the user and the repairer. This protects the user as well as the repairer. Again, from the standard, the service facility shall seek to obtain all necessary information and data from the user. This shall include reference to relevant type of protection standard, scheduled drawings, and information related to previous repairs, overhauls, or modifications. The repairer should be sending all this information to the user. If the user doesn't ask for it, the repairer won't send it. The user should be asking for this information so that they have that information to put in what's called a verification dossier to make sure that that equipment that they are putting into a hazardous zone is safe to do so. Let's talk about documentation. What should be transferred between the user and the repairer and vice versa. The service facility should keep all documentation for 10 years. Again, this is a requirement of the repair standard. If there was an incident to occur and you repaired that equipment 7 years ago, you would be expected to be able to pull out the paperwork and show what had happened. And this is for the user as well as the repairer. All relevant drawings to be kept with the job record. If you had a new shaft or a new fan cowl or something manufactured because you could no longer get the manufacturer's parts, which is allowed in the repair standard, those drawings need to be kept so that you can prove, if an incident occurs, how and why and the dimensions of the new part that you manufactured was on that job. All measurements and readings, electrical and mechanical, should be in the paperwork. And all the agreements between the user and the repairer should also be in that record for that particular job. Now, this is the documentation that should be sent to the user according to the international standard. Details of all the faults detected. Full details of the repair and overhaul. List of reclaimed or replaced parts. And the results of all checks, tests in sufficient detail to be useful if required by the next repairer. A comparison of the results against the criteria that have been used to determine compliance. So as we saw in an earlier slide, the maximum permissible gap from that terminal box lid was 0.2. So you should be sending information to the user, or the user should be requesting the information of, okay, the measurements, what would you measure them against? You've said that the terminal box lid was 0.15. What's the maximum? Then the user can then ascertain whether or not it should be machined or it's acceptable. Because remember, the user is putting this equipment into a hazardous zone. If the measurement is 0.195, it's very close to the maximum. Yeah, again, the agreement between the user and the repairer needs to be in writing, then everybody's covered. a copy of the user contract or order, again, should be sent, and then a recapitulation of markings applied in accordance with Annex A. Annex A is the marking which repairers put onto a repaired piece of equipment. If you're repairing to scheduled drawings, you should have a repair label with a square on it. If you are just repairing to the standard to which it was manufactured to, you put an inverted triangle on it. Okay. Any questions so far? I seem to have been rabbited on like I do, unfortunately. That's my problem.
There's a question coming from Jeff Cook, if you want to have a look.
Jeff Cook. Is this the famous Jeff Cook for who I've known in the past?
Yes, yes, you can't get rid of me. Sorry, Carl.
How are you, Jeff? You okay?
Yes, very well, thank you. Yes.
Good. Nice to speak to you. I was going to contact you, but we'll do that at another time. Yeah, what's your question, Jeff?
It was just going back to your point of 3.28 for the user. So it's a sort of an assumption on my part, my understanding, but am I right in saying that for that the user should carry a competency of Compex EX14?
Yes, again, I'm focusing on the repair aspect of things. 14 is installation and maintenance, isn't it? And that would be more relative to Compex and so on and so forth.
Oh, okay, right.
I'm looking back. I mean, Jeff. I mean, for everybody else listening, Jeff is one of the people who used to receive paperwork from myself when I used to work for an IECX repair facility, and he was one of the very, very few engineers that did everything correctly. He would not fit any equipment until he got the correct paperwork in place, which is the correct procedures. And there's lots of people who I sent information to, and they would say, "What's this?" Jeff knew, and I always revert back to what Jeff was asking for when I'm doing these courses. So yes, you knew what you were doing, Jeff, didn't you?
That's very kind of you to say so, but yeah, maybe you can reiterate that to my boss. Yeah, thank you.
Anytime, Jeff, anytime. Okay, right, moving on. So yes, repair labels, they need to be on. There's a lot more information on here that is actually needed, but these are our AEMT repair labels. You can manufacture your own as long as it has the R in the relative triangle or square. It has the repair standard in there, your company identification, the repair reference, and the date. That is all you need. This is all the standard is requesting of you. You can put standard numbers there, which you've repaired it to if you want to, but this is just extra information that the AEMT have added to their repair labels. Again, if you're repairing EX equipment, you should have a copy of BSEN IEC 60079 Part 19, 2019, not 2015, not 2011. Those are the old, outdated repair standard. The latest repair standard is 2019. If you are repairing without the scheduled drawings, your paperwork should contain this information. Okay, it is telling you that you are repairing it without the drawings, that you have got, you're repairing it to the standard it was manufactured to, that you do not have full compliance with the certificate or the drawings. Okay, and that all the special conditions of use have been reviewed. Special conditions of use are explained, or you know that the special conditions of use, when you look at the certificate number, it will have an X at the end. Those special conditions need to be looked at and to see if they are relevant to any of the EX protection. For example, flame paths. Lots and lots, given out the time, lots and lots of manufacturers now are putting special conditions of use into the certificate and relating it to repairs. Now, why they have it for use and then to do with the repairs, I don't know. Manufacturers are there for a reason. Manufacturers like to sell new equipment. So they want to make it as difficult as possible for repairers to do their job. A lot of the certificates now say, without the scheduled drawings, the flame paths cannot be reclaimed. If you come on an EX course by the AEMT, or if you read the standard and you read it correctly, you can do that. If you're following the repair standard, you do not need the schedule drawings, but you need to state in your paperwork the route you are going through to do this. So, tests that should be performed on equipment. The standard has two references. It states should, which means you have a choice, and it says shall, which means must. Lots and lots of areas of the standard where it says that. And people say, oh, you can't do that. It says you should do this. No, it should. You have a choice. It's only when it says shall that you must do it. Coreless testing should be performed because this will identify damage to the core. If you have damage to the core of an electric motor, it can cause heat, hotspots. If you are causing heat, it would change the T class. The T class is on the equipment to make sure that no gases or dusts are ignited on the outside atmosphere. Surge testers, they give accurate readings of the conditions of the windings and insulation. They will tell you if you have any shorted turns or so on and so forth. Just a normal meter will not show that in great detail. Again, this could cause heat or problems when it's on site, and we don't want that. There's mention of overpressure testing. There was a guy going around the world from Australia who I think had shares in pressure testing equipment, was saying that whenever an EXD piece of equipment was dismantled, you should perform a pressure test. No, you don't. The standard says an overpressure test shall be conducted when structural repairs of the enclosure have occurred or the integrity of the enclosure is in doubt. That is the only time you need to perform a pressure test. And remember, the pressure test is only for EXD because you are seeing if the concept can still contain an explosion. So general testing, when any EX motor is rewound, the following tests need to be performed. Oh, there we go, went ahead of myself. Now, continuity and phase resistance, fairly straightforward and simple. No load test, you're putting the motor on a bed and you're running it up to full voltage, checking the speed, making sure there's no vibration. Locked rotor test is the one that people get a bit worried about. And lots and lots of people said, yeah, we perform locked rotor test on all our equipment. Do you really? So if you have a 400 kilowatt or 1,000 kilowatt coming into your building, you're telling me you have the supply to do a locked rotor test on 1,000 kilowatt. A locked rotor test is to check the insulation on the new winding. So you supply a voltage to the piece of equipment with the rotor locked until that piece of equipment has reached full load current. You can imagine what a 500 kilowatt, 1,000 kilowatt full load current would be. So if you can't perform a locked rotor test, put it in your paperwork. These are only tests that should be done. Should, not must. They should be done. But you need to put in your paperwork the tests that have been done and the tests that have not been done. Because the user could look at the standard and quite happily assume that all of those tests have been carried out before they put it back on their bed, on their system, on their plant to start doing the job. Okay. Again, insulation test and a voltage withstand test. So the AEMT EX register and IEC EX certified facilities. What are they? The AEMT EX register is what it says. The AEMT has quite a lot of companies who are registered that meet our criteria, which is on the next slide. If you want to become an AEMT EX register or get on the AEMT EX register, the AEMT will audit your facility and we will assist you where required to meet the requirements. But you must meet the AEMT requirements. A lot of people see it as a stepping stone towards IECX certification. We follow their instructions. We follow what they are requiring. Not in maybe as much detail as they are. Again, we could talk about that for hours, but we do follow the same steps and criteria of what they require. Our AEMT training is actually recognised by the IECEX. We are an official recognised training provider. So the training we give is the same sort of thing that I would, if I'm auditing one of your facilities, I would follow the IECX criteria. To get on the AEMT EX register, you need at least one responsible person of management status who has been on one of the courses. We say management status. That person who's responsible, the responsible person, is the person who is signing off the equipment to make sure it complies with everything. If you don't agree with what one of the operatives have done, that person needs to go out and tell them it's not right. It's very difficult for people of equal standing in a company to tell somebody else that what they've done isn't right. This is why it is far better that a responsible person is of management status, whether it be a supervisor, a foreman, or somebody who is above the operatives. You need at least 2 certified employees who are the operatives and been on the hazardous area course, and of course in the last 3 years. Again, we have refresher courses every 3 years because the standard and information in the standard changes. You need to have some sort of quality system in place. For example, ISO 9001. Calibrated equipment, and make sure you have the correct size of equipment to measure and check the equipment in your building. There's no point having some 300 mil verniers and having a 500 kilowatt. You will not be able to measure with that equipment, will you? And to make sure that all your repairs are carried out to the latest version of 607919, the latest version. Not the one from 2011, that's 10 years old. IECEX certified service facilities. Everybody who is an IECEX certified service facility is on our EX register because there is far more criteria they meet beyond what we require. So they automatically come on our register. The IECEX will audit your facility. Make sure everything is correct, in place. Your suppliers are also audited by yourself. You have a list of recommended suppliers, very strict, very stringent. The facility will undergo regular audits by IECEX to make sure that you are still complying. If you don't comply, you will get non-compliance and you will have to put that right. Otherwise, you may lose your license and you will not be a certified facility anymore. The IECEX certified service facilities meet the requirements of all users. It gives the user a sense of a bit more relaxed, and it doesn't feel the need to go and inspect or audit that facility because IECEX audit that company. And it would be, all they probably would need to do is a copy of that company's certificate to go in their file to say, I use this company because they are IECEX. It's not cheap though to become an IECEX certified facility, but you will usually find that they are probably the best. But again, this is all what the customers are asking. It's strange and it's quite scary, but anybody can repair EX equipment. My son can repair EX equipment in his garage and send it off. It might not even be right. It is the user that is responsible to ask the questions of the repairer that they are doing the job correctly and to the standard and to a certain criteria. So the AEMT, as I mentioned before, we do training. This training is recognised by IECEX. We have modules 1, 2, and then we also have refresher training every 3 years. We have these training courses all around the country. We have them in Aberdeen, we have them in Loughborough, we're looking to have one in Watford, and we have them in York. Depending on requirements for people, we're even thinking about having one over in Ireland. We will travel to where people require this training. For any information on the training, contact the AEMT on the training email, training@aemt.co.uk.